Yeah, so just to introduce myself, my name is Joe Miles. I'm the founder of Atamate. I'm going to talk to you today about reducing energy and how to decarbonise buildings. Obviously, it's 10 minutes, so it's going to be a quick rattle through, so apologise for that. So just to introduce ourselves, I'm actually a building service engineer by background. We've developed a technology platform, which is the Atamate system. We also are fully qualified as building service engineers, and we're also a M&E contractor, which is quite important, particularly we find when we're working with local authorities and government bodies because they like us to supply and fit. What our technology is that we collect a lot of data from the buildings in summary. So we put sensors in all the rooms, we meter. The sensors are picking up things like carbon dioxide levels, temperatures, humidity, ambient light, air pressure, at least 10 different sensors, collect all that information together, and then we can control all of the plant in the building. So all the mechanical and lighting systems, all the electrical systems, so can control heating, ventilation, air conditioning, and such like. So the key point is it's all done over Bluetooth mesh technology. So it means that there's no cables to run. That's a lie, there's very small cables. So if we're going into this building, typically we'd take a power supply off the lighting circuit, permanent live. But it's very, very simple to retrofit, and it's all installed by electricians. So again, all of this helps to keep the price point down and when it goes into buildings. As well as doing energy, there's sort of 5 value propositions. I'm only going to talk about energy today. So other than energy, it's also about wellness and comfort. So this is typically picking up air quality data. In larger buildings also, it could be things like Legionellas, where you've got sort of dead legs and such like on pipe work. There's a whole maintenance piece because we've got all this digital information. So if you click a light switch in the building, we'd expect to see a change in ambient light. If there's no change in ambient light, we'd say there's a failure in the lighting system potentially. Same with heating. If you turn the heating on, we expect the heating to go on at midday, 9 o'clock or whatever. 10 minutes later, 15 minutes later, if there's no change in temperature, then it's a good indication there's a problem in the system. So you start to create a sort of feedback loop across all systems which traditionally haven't been closed loop. There's a whole security piece. Most of it's sort of common sense. The one bit that's probably a little bit unusual and interesting is we started to look at dementia care and keeping people with dementia in their own homes for longer. And so using exactly the same platform, same technology, there's things we can do over that. And then finally, there's sort of building management. I'm conscious I'm going through this quite quickly, just simply because there's not a lot of time in these 10-minute sets. So if we focus on how do we reduce energy and route to zero carbon in buildings, we've kind of got this sort of upside-down triangle model. So you start off by collecting a lot of data and understanding the building. After that, we do what's called simple wins. So simple wins is using the information we're collecting to reduce the energy. So what we can see here is you've got a time series data. So down the bottom, it's roughly sort of 2 weeks. Starting from the bottom, there's occupancy data. So occupancy is a combination of either passive infrared, like a security alarm, or it can be radar information, and then also CO2. So we typically look for decay in CO2 to know when a space is unoccupied. And so you can see when there's occupancy in the space, and then the red bar is when the heating's on, and you can see sort of pink color on the left-hand side. It's turning on and off to keep the temperature current in that space. And then when we take control over it, then you can start to see occupancy-based heating. And there's typically very big energy savings associated, with occupancy-based. So in non-domestic buildings, this is actually in a student accommodation, but in non-domestic buildings, quite often now, for an office, for instance, you're finding no one's there on Monday and Friday. And so, by linking the occupancy to that, there's really significant savings. And it's typically, we find at least 30% energy savings in a building in most non-domestic buildings. And there's typically a sort of sub-3-year payback on that straight away. So if we look now, so this is looking at again, time series data. It's actually a different building, different time series, so apologies for that. But what you're looking now is the metering data. And so we get very granular data. So typically we'll measure all the circuits in a distribution board because you get a lot of information out of it. So each of the different colors is different devices. The cooling's actually aircon, but sort of mislabeled heating and such like. And you can see that when we turn on the control, there's a significant amount of energy saving related to that. So just to not only talk about heating, but just briefly talk about wellness. So here we've got time series data again. At the top now we've got carbon dioxide, then we've got humidity as the second layer, the blue line. There's the orange is the temperatures, green again is the occupancy information. At the bottom, the sort of blue spiky is when fans are turned on and off. So what we can see is before, on the bottom sort of left, is you can see that there's averaging around sort of 1,000 parts per million or something, for carbon dioxide around about there. And you can see it's very spiky, the carbon dioxide, and in fact the humidity as well. So, and then when we take control over it, you can see that the line flattens out. You can also see that the bottom line, the blue, the fans are being turned on a lot more, to reduce that carbon dioxide level. So, the problem is, as an energy manager, you're probably increasing the amount of energy you're using in that building because you're now bringing more cold air in, so you're going to have to condition that air more. But actually, it's a trade-off between how healthy you want your space compared to how much energy you can use. And you can see afterwards, we're down to sort of 500, 600 parts per million on the carbon dioxide. So, whoops, I've gone the wrong way, apologies. So we've done some simple wins in the building. So now we want to know how to get rid of the gas boiler or the oil boiler that we've got in the building. How do we move to electrical heating? And so we're going to use the data to how we get that upgrade path. And so, the real challenge in facing the UK, so this is not our data, this is national data. The green line is, so what we've got is years along the bottom, so you can see over a number of years, and the green is the electrical, and you can see there's sort of, there's a pattern, but it's not huge peaks, whereas natural gas is a huge peak over winters, because we're getting all our heating, well not all, but the vast majority of our heating is from natural gas. There's a real challenge in this country about how we decarbonise the heating system. So that's the sort of scale of the challenge. And the two things which are really going to drive this in existing buildings are the use of the building, so the occupancy of the building, and the building form. And by the building form, I mean really the sort of fabric performance of the building. So if you've got, we've got to measure how airtight and how much insulation that space has got. So we'll be looking at this on a room by room basis. And then from that, we also are looking at how much use of people coming in and out. And off the back of that, then you can optimize the systems that you're going to put into the building if you are choosing to upgrade the systems. Quite often, people are using existing systems, but we're looking to do it in a more efficient way. So, I mean, just to put this in sort of fairly simple terms, if we're looking at occupancy, which we think is the biggest driver, and certainly our data is showing the biggest driver in terms of how you decarbonise those spaces, on what we've got is got a hospital ward, which is sort of occupied 24/7, so that's really high occupancy use. And down the bottom, we've got a primary school. So primary schools, typically only used for about 6 hours a day, and they're kind of totally weird because, when that room's in occupation, you've suddenly got 30 kids in there. They're all bouncing around. They've probably got a few computers, so actually you've got a lot of internal gains as well. So, what mechanical systems would you optimize in this building? So if we look at starting at sort of, the permanently occupied, obviously the best thing is to do fabric improvements. So we've got external wall installations, but clearly that's not possible or affordable to do in the vast majority of the UK's building stock. So, probably you're looking at, heat pumps, and so you're looking at particularly air-to-water heat pumps, which particularly when you're looking at large buildings, they're going to be quite efficient. As we move down into less, more intermittently occupied buildings, air-to-air heat pumps are much more efficient, so that's an air conditioning system in essence to most people. So they'll have a higher coefficient of performance, so they'll give a better. For less electricity use, you'll get more energy out of them typically. And then we've got direct electrical. So two examples: direct electrical. So we've got just a plain panel heater. And then we've got infrared. So, something like infrared might be really appropriate if you're looking at a, fire station and you're looking at a garage where, there's, you basically got people coming in and out the whole time. So you'd be choosing the most appropriate system. I put solar in there just because if I don't put it in, people are going to complain there's lack of renewables. The problem with renewables is they don't really, solar in particular, solar doesn't really help decarbonise heat. Because in the UK, you get 8 times more energy in summer than you do in winter. So it's not, it's not really relevant for, decarbonisation of heat. And so when you're putting solar in, you've got to be thinking about what your peak load is in summer. And obviously that's changing as we're going to, electric vehicles and such like. But it doesn't really help in most cases. So batteries are probably much more efficient. Yeah, that's me. So it's a very quick rattle through. Got a minute for questions, but I have actually we've got a stand. Sorry, thank you. We've got a stand sort of the far end over there somewhere. So please come and, if you want to know any more, please come and question me.
Rob, question.
Probably a question on everyone's lips is, where are you at? Are you looking for investors? How many customers have you got? Where are you at in the cycle?
Yeah, so we're sort of scale-up stage now. So we've just done 10 buildings for Bassett Law Council. We've done our first MOD project. We're doing Bristol and Western NHS Trust are putting us into their first big NHS buildings. We've done a whole range of buildings. We've done Airbus helicopter hangar. We've done Shell took us to Oman. They told us we're global leaders in this space to go and decarbonise a big oil offloading terminal. So we're in domestic buildings. You know, we're in a whole range of buildings. But yeah, we're on that journey. I think we've literally just won 10 more buildings with Oxfordshire County Council. We've done 2 with Oxford City Council. So yeah, we're beginning to accelerate. So it's exciting times for us. So, but yeah, we love to talk to you guys. We want to talk to anybody who's got buildings who pays their own energy bills. And the problem is a lot of the private sector, the landlord doesn't pay the energy bill, the landlord's not incentivised to put in any of these controls, and the tenant's quite often not allowed to put the controls in. So, you know, that's taken a while to sort of penny to drop, but we've worked that out now, and consequently we're very interested in anybody who's paying their own energy bills, and that's a lot of the public sector.
Brilliant. Joe, thank you so much. Really great to hear your story.